Hi again. Today we will revise the part one concerning area and surface area from the chapter one of this book. Okay? So first of all, we should give a short review about the area of particular two-dimensional shapes and quadrilaterals. Okay, so we should know that the area of square is side by side. Okay, unit length of squared, we mean by meter square, centimeter square, millimeter square, kilometer square, hectometer square, and so on. Area of the rectangle, length by breadth. The triangle, 1/2 by the base by height. The parallelogram, the base by height, and rhombus or kite. Rhombus or kite, 1/2 times the lengths of diagonals. And the trapezoid equal to the half or by the height by the sum of the bases or the parallel sides, the lengths of the parallel side. So, and if we seek to find the area, you should know that when we are talking about area of two-dimensional shapes, we say simply area. But if we talk about three-dimensional space, we say surface area. It is very recommended to divide the composite shape into simpler shapes, okay, before evaluating its area. Why? How? Using horizontal cuts or vertical cuts or oblique cuts, okay? So we decompose and divide each composite shape to find parts that are similar to particular shape into the 2D, like square, rectangle, rhombus, trapezoid, and so on. We should know that the area of a whole circle of radius r, it is equal to pi r squared, and the sector, only a sector of a circle of radius r and angle alpha, because any sector can be defined with as a part of a circle, but with a given angle. It is alpha over 360 by area of the circle. So we know that the area of the circle is pi r squared, so alpha over 360 by this one. So how to calculate the area of each sector correct to 1 decimal place? For example, here we have alpha, we have the radius, so it is equal to alpha 60 over 360 by pi r squared. Pi r 5.2 squared. So to obtain 14.2, we use here the unit of length is centimeter, the length unit centimeter, so centimeter squared, and so on. All these examples are about sectors with different or radius and different alphas as angles. Find the area of the following shapes. Normally, all these shapes are of composite shapes. So, as we said before, it is a deep recommended. It is very recommended to divide this composite shape into simpler one. Okay, using vertical cuts or horizontal cuts or oblique one. Here we can, for example, cut this one or this one. It is recommended to cut, for example, to the least of cuts. For example, here it is recommended to have one cut instead of two cuts, for example, because we have with the horizontal cut that we have here, we'll obtain two simpler shapes. Okay, and in this example, if we use two vertical cuts, or we can use two horizontal cuts, we'll obtain rectangles and squares. So for example, we'll obtain here 3 rectangles with different lengths and breadths. So normally will obtain A1, A2, A3, and we can identify the lengths of length and breadth of each one. For example, here we have this one with the same mark here, with the same mark here. So normally, if this is equal to 3, so with this step equal to 3, and this side equal to 3, 3 and 3 and 3. So the whole height is 9. So normally it is a 9. 9 minus 3 is a 6, and this one is 3. So normally It is easy to complete. 9 by 4 plus 6 by 5 plus 3 by 6. This is easy also. Okay. And so on. And the following one we have also, if we divide, we use the horizontal cut here, we will obtain triangle. A triangle with a base equal to the diameter of the circle. The diameter of the circle is 8 millimeter. And when the diameter is 8 millimeter, the radius of the circle, which is equal to this part, is 4 millimeter. If we have a 4 millimeter here, that was the height here, equal to 16 minus 4 equal to 12 millimeter, and we use the area of the rectangle in the half by the base by the height. Okay, and we the area of the semicircle in the half of pi r squared, and so on. Moving on to the evaluation of the area of. Sorry for the bad connection again. Moving on to the surface area of particular 3D shapes. When we want to find the surface of 3D shapes for solids, we say surface area instead of area. So how? The surface area of a solid, the sum of the areas of all its individual faces. To determine this surface area, we should follow the following steps. Identify all its faces, calculate the area of each face, and then we sum these results. And it is also recommended to take the bottom face as a reference to draw the bases next to. For example, we have the first example is for the surface area of a rectangular prism. First of all, we have a rectangular prism. Rectangular prism, we mean 4 rectangular lateral faces with 2 rectangular bases, for example. We have a 4, like 1, 2, 3, and 4. We have a 4 rectangles and 2 sides. So normally we have a 6 rectangular faces. Okay. First of all, we use it is recommended to take the bottom face. We take the bottom face with length 9 and breadth 4 as a reference. And we draw all the faces. For example, we draw the front one, the back one, and the top, all okay along each other, and we identify the lenses. So normally we draw the net. We identify the edges, and we transfer the edge lengths to the net. So normally we have a 9, 4, and then we have a 9 and 6. So normally we have a 9 and 6. And secondly, we have a 4 and we have a 9. So normally we have a 9 and we have a 4, and so on. So we have a 6 rectangular faces. So we have, if we we can clearly see that we have the bottom and the top are identical. So we can group them in the same category, the front and the back, with each other. And the left side and the right side are identical, congruent with the same lengths. With same edges. So normally it is easy to calculate the 1 and we multiply it by 2. The area of one of these face with the bottom, for example, at the bottom we have a 9, 4. So that is a 9 by 4 and we multiply it by 2 instead of saying 9 by 4 plus 9 by 4 and so on. And the same for the front. The front is 9 by 6. And you multiply it by 2 instead of saying 9 by 6 for the area for the front and the area for the back 9 by 6 and so on. So to obtain 228 centimeter and the square. And also you can, for example, use the same way by drawing the net, identify the edges, transfer the edge lengths to the net, and to complete by yourself the following calculation. It's very easy also to find out how to proceed with the surface area of triangular prism, how to distinguish between a rectangular prism and triangular prism. Rectangular prism, we have a 6 rectangular faces. With the triangular prism, we have a 3 rectangular prism with 2 triangular faces. With 2 triangular, 3 rectangular faces with 2 triangular faces. Also, we can draw the net, identify the edges, transform the edges lenses to the net. So it is easy here to it's clear to see and to find that we don't have any congruent faces. But however, we have only the triangles are congruent. So normally we have area of 2 congruent identical triangles, and we have have to find the area of each of the rest of 3 triangles, and we sum all to obtain the result and the surface area of the given triangular prism. So the area of a triangle, it is the half of the height by base. It's easy to say it is a 1/2 by 6 by 3.3 by 2 because we have 2 triangles. And for the following one, it is a 4 by 8, it is a 6 by 8, it is a 5 by 8, and we add all these numbers to obtain the following result. And you can also practice by yourself on the following exercises how to find out the surface area and and evaluate the surface area of a rectangular prism and also triangular prism. And we should know that we also always have, and we should remember that when we And finally, we should know that in any right-angled triangle, we can use the Pythagorean theorem, where we can say, for example, in these following examples or samples, we have right triangles, the front and the back side, the front and the back side face, the front and the back face, okay, are given as right angle triangles. So we can use Pythagorean theorem, where the hypotenuse square is the length, the side opposite to the 90 degrees. The hypotenuse square, also the hypotenuse square here, the hypotenuse square is the x squared, because the hypotenuse is x, So x squared here, x squared here, x squared here equal to the sum of the lengths of the other sides of the same triangle. So it is a 15 squared plus 10 squared. Is it 5 squared plus 20 squared? Is it 3 squared plus 4 squared? And so on. It is an equation. It is a given equation. So we find easily by squaring, by evaluating the square root of the given number to obtain the length of the unknown edge. Thank you for listening. Bye-bye.